Numerical number 6, cross product of two vectors. In the diagram, y and x be two mutually perpendicular axes, and we can calibrate different values along x-axis. This is -1, -2 and -3 along negative y-axis. Now we can denote the position of the point P having position coordinates 3, -1, 2, and we have another point which is Q having position coordinates 1, -1, 1, -1, 3. These are the 2 points P and Q, and we have another point that is capital R having position coordinates 4, -3, 4, -3, 1. We can connect Q and P and R, and also Q and R are connected. QP has direction. We can denote connect Q and P properly. Drawing a straight line. QP has direction from Q to P, and PR has direction, and a vector A is represented in magnitude and direction by the straight line QP. We can denote the direction of the straight line PR. Another vector B is represented by the straight line PR in magnitude and direction. And also you can denote the direction of the third side, that is QR. Now we have to find the area of this triangle QPR. Vector QP is given, which is vector A. Vector QP, how to find vector QP? By subtracting initial position coordinate from the final position coordinates, that is P minus Q, and position coordinate along y-axis is -1 of the point P and -1 of the point Q. Actually it should be P minus Q, final position minus initial position. Then for the rectangular component along z-axis, 2 is the position coordinate of the point P along z-axis, and -3 is the position coordinates of the point Q along z-axis. 2 minus -3 k cap, and vector QP is equal to vector A. That's why it can be written as vector A. This is vector A equal to I cap minus 2j cap, 2I cap minus 2j cap. Sorry, it should be -1 plus 1 means 0j cap. 0j cap plus 5k cap, because minus of -3 becomes +3 plus 5k cap. So we get the value expression of vector A. Vector A means the straight line vector QP. This is equation 1. Similarly, we can find the second vector B, that is which is represented by the straight line vector PR. Now vector PR is what? Vector PR will be obtained by subtracting the position coordinates of the point R, the position coordinates of the point P from the position coordinates of R, that is R minus P. 4 minus 3 I cap, that is the position difference of position coordinates along x-axis, then -3 of -1 difference of position coordinates along y-axis of the point R and P, plus 1 minus 2. 1 is the position coordinate of the point R, minus 2. 2 is the position coordinates of the point P along z-axis. So now in place of vector PR, we can write vector B, or comma vector PR is equivalent to vector B. Vector B equal I cap minus 2j cap, minus 3 plus 1 means minus 2j cap, and here minus k cap. 1 minus 2 means minus 1, minus 1 into k cap means minus k cap. So we get the expression of vector B, which is I cap minus 2j cap minus k cap. This is equation 2. Now we can find the cross product of two vectors A and vector B. This is determinant of I cap, j cap and k cap. And we have to put the rectangular components of vector A because vector A comes earlier, 2, 0, 5. And vector B comes later, that's why you have to put the rectangular components of vector B below 2, 0, 5, that is 1, minus 2, minus 1. So if we explain, vector A has rectangular components 2, 0, 5, that's why you have right, and A comes earlier, that's why you have to put 2, 0, 5 first. Then vector B has rectangular components 1, and this minus 2 will be there, minus 2, and minus 1 will be there. So now we have to find the expression of vector A cross B. Bracket 0, 0 into minus 1 minus 5 into minus 2. For that we have to block the column of I cap into I cap, plus for j cap it should be 5 into 1. By blocking the column j cap, immediate right hand side component of j cap is 5. 5 into 1 minus of 2 into minus 1 j cap, plus for k cap we can block the column k cap, then 2 into minus 2 minus 0 into 1 k cap. So 10 I cap, finally we shall get 10 I cap, that is 0 plus 10 I cap, 0 plus 10 I cap, and then 5 plus 2 j cap, then 4 minus 0, minus 4 or minus 0 k cap. It is not minus 2, it should be minus 4. Therefore vector A cross vector B equal 10 I cap plus 7 j cap, 10 I cap plus 7 j cap minus 4 k cap, minus 4 k cap. It should be minus 4 k cap, not minus 2 k cap. It should be 4, not minus 2, minus 4. So finally we get vector A cross vector B as 10 I cap plus 7 j cap minus 4 k cap. Now we can find the magnitude of vector A cross B. Vector A cross vector B is equal root over 10 square plus 7 square, 10 square plus 7 square plus bracket opened minus 4 whole square, which is 1 root over 165. 100 plus 49 plus 16. 16 minus 4 whole square means 16. Therefore, mod vector A cross vector B, mod vector A cross vector B is equal root over 165. 165. Root over 165. Now you have to find the area of the triangle. Mod vector A cross B equal root over 165, which is 12.845. Mod vector A cross B will be 12.845 to approximately 12.845. Therefore, the area of the triangle QPR, not OPR, it should be QPR, is 12.845 unit square. Now triangle QPR, not OPR, it should be QPR equal half mod vector A cross B. This is wrong, so it is this part. Therefore, triangle QPR is equal half mod vector A cross B. Mod vector A cross vector B is equal to 1 by 2 half into 12.845. We know that triangle formed by two vectors is a half of magnitude of two vectors. So finally we get 6.4225. 6.4225. Therefore, the area of the triangle QPR is 6.4225 unit square. The area of the triangle OPR is 6.4225 unit square. So this name of the triangle will be QPR, not OPR. That was wrong. In the diagram, QPR is the triangle and vector A is represented by the straight line QP and vector B is represented by the straight line PR. And QP and PR are taken in the same order, and area of triangle QPR is equal to half mod vector A cross vector B. Half mod vector A cross vector B is the area of the triangle QPR. Hence, the area of the triangle QPR is 6.4225 unit square.